In this final section, we're going to take a look at the limit again. But instead of using infinitesimals, we're going to redefine the limit without having to go to the hyperreals. And this is how a limit would traditionally be defined in a calculus class where they're not using hyperreals, which is the majority of calculus courses you would have taken here at Collin. So I want to make sure that you have this bit of information with you. I'm hoping that by now your intuition of the limit is well established. But if you're in, Cal 2 class with some other professor and they bring up the idea of epsilons and deltas for the limit, I don't want you to be completely in the dark. I want you to have some sense. And I'm going to try to tie it in how the formal epsilon delta definition of the limit is directly related to our hyperreal definition of the limit. So first off, let's make sure we remember what our hyperreal definition is. So we say that the limit as x approaches c of f of x equals L. Well, what does that mean? That means that if x is infinitely close to c, typically not equal to it, then f of x is infinitely close to L. Now, let's investigate this idea a little bit further. What does it mean that x is infinitely close to c? Well, it means that x is just equal to c plus some infinitesimal. So we could change this to say that if x is equal to c plus some infinitesimal delta, then f of x is equal to L plus some infinitesimal epsilon. Right, so that's all we're saying. That if and what are epsilon deltas? Where epsilon and delta are infinitesimal numbers. Right. So another way we could have looked at this, instead of having equality, I could have subtracted here. And so maybe I say that so these are all equivalent statements of saying the exact same thing. This limit exists. So let's subtract. So if x minus c, if the difference is an infinitesimal, then f of x minus L is an infinitesimal. And so I'm just playing around with the definitions. And again, what are epsilon deltas? Epsilon and delta are infinitesimal numbers. Three different ways of saying the exact same thing. Each of these three sentences are equivalent. Now I'm going to play around more with this idea here to kind of see if what if we kind of loosen up this requirement that epsilon and delta have to be infinitesimals, and kind of get an idea of this idea of the limit, meaning that as long as x is equal to c plus some number, then f of x, the same x, so this x getting put into here, would be equal to L plus some little number. So where that might come into play, let's consider a scenario where, say, the temperature in Celsius with respect to pressure measured in pascals of a simple machine is modeled by the equation T of P equals 5P. And further, it is desired that the machine run at a temperature of 25 degrees Celsius plus or minus a tenth of a degree. Right, so what range of pressure will guarantee that the machine's temperature stays in this range? So here's where what I'm talking about, that I want to know the output of this, the function, right? So I know that T, the temperature, is equal to, say, 25 plus or minus 0.1. What this is really telling me, right? So if I if I subtract this, this tells me that negative 0.1 is less than or equal to t minus 25, and that's going to be less than or equal to 0.1 because the temperature is equal to 25 plus 0.1 or minus 0.1, right? So it's somewhere between 24.9 and 25.1. And this should be familiar. This tells me that the absolute value of t minus 25 is less than or equal to 0.1. So this is what we want. We want this to be true, and we need to know, well, so this is what we want. We want this to be true. And how do we control it? Well, we want to control it with the pressure. Well, it's pretty straightforward. I know that if that t of 5 will give me 5 times 5, which is 25. So if if P is equal to 5, then temperature is equal to 25. Right? So if our pressure is 5 pascals, our temperature will be 25 degrees Celsius. But there's a little bit of wiggle room allowed here. I can be up to 25.1 degrees Celsius or as low as 24.9 degrees Celsius. So, which means I get a little bit of wiggle room on the pressure, and I like to know what kind of accuracy and my pressure, what range does it have to be? So let's come back to this. So again, I want to know, so P needs to equal 5 plus or minus what? Right? What's my error allowed in my pressure? Or if you like, I want to know when is negative delta less than or equal to P minus 5 less than delta, or putting it back in absolute values, when is P minus 5 in absolute values less than delta, that would force this to be true. Because my pressure, if I put it into my function, will tell me the temperature. So what kind of bounds do I need on my pressure, being close to 5, to force that my temperature is within a tenth of a degree of 25? And we'll start with what we want to kind of give us to guide us in this. So we want, let me write this down. So we want T minus 25 to be less than or equal to 0.1. Well, what's T? Well, T is 5 times P. So this is true if and only if 5P minus 25 is less than or equal to 0.1. Now, I've got a 5 here and a 5 here. I can do some factoring. So this is true if and only if 5 times P minus 5 is less than or equal to 0.1. And lo and behold, isn't this exactly what we're kind of trying to get a handle on, is what does P minus 5 need to be less than? Right, we want to find this delta that makes it true. Well, I can divide both sides by 5, and this tells me this is true if and only if P minus 5 is less than 0.1 divided by 5, which is 0.02. So, what does that tell me? As long as P, so if pressure is equal to 5 plus or minus 0.02, then temperature will be 25 degrees plus or minus a tenth of a degree Celsius. So as long as my pressure is 5, I can go as high as 5.02 pascals or as low as 4.98 pascals. Okay, so what this is really telling me that 4.98 or all the way up to 5.02. As long as my pressure is in this range, my temperature will be within 25.1 or as low as 24.9, which is what we wanted to know. As long as the pressure is between 4.98 to 5.02, that's the range of my pressure. If that stays in there, my temperature will stay in the range I want.